All right, so I'm going to show you how to find the equation based off of the graph when we're talking about rational functions. The first thing we will do is to look for the x-intercept. The x-intercept is going to indicate what factors we have in our numerator. After that, we're going to look for the vertical asymptote, or totes. These are going to indicate the factors that are in the denominator. Then we'll look for any holes. Holes in the graph indicate that there was a factor that was both in the numerator and in the denominator. They don't affect the shape of the graph other than to say that you cannot equal the number at that location. Finally, we've got two different types of horizontal asymptotes. One would be on the x-axis. If it's on the x-axis, one thing that tells us is that the numerator has less factors than the denominator. So that's kind of a good quick way of checking to make sure you've done things properly. What we're going to do with it is to check the y-intercept for a negative coefficient, or whatever the coefficients might be. So we're going to set our x's to 0 and identify what that would equal. And then we figure out what number does that need to be multiplied by to equal the actual y-intercept. So you can think of it when we set them all to 0, all the x's to 0, what we'll get is kind of our tentative y-intercept. And as we compare that to the actual y-intercept, we figure out what we need to multiply our equation by to get the y-intercept we were supposed to get. Or if we've got an asymptote at y is equal to a over b just being some number, that indicates that the numerator is going to be multiplied by a, the denominator is going to be multiplied by b, and our numerator and denominator will have the same number of factors. Okay, so coming down here, let's start with the x-intercepts. Now, we've got our asymptotes here, and it looks like it gets closer to the x-axis, but it's never actually touching here. So currently, in my rational function, I don't have any factors from x-intercepts. All right, next we'll look at the vertical asymptotes. We've got two vertical asymptotes. So we've got one at x is equal to a positive 2. Now that positive 2 is going to create in the denominator the factor x minus 2. Because when x is a positive 2, that's when this is 0, and we can't divide by 0, and that's why that asymptote exists right there. The other one is at x equals negative 2, so that creates the asymptote x, or the factor x plus 2, down in the denominator. All right, so now we've dealt with our vertical asymptotes. Next, we'll check for any holes. We don't see any holes in this one, so we can skip that step. Next, we look at horizontal asymptotes. We do have a horizontal asymptote, and it is there on the x-axis. So because it's on the x-axis, we're going to check what our tentative y-intercept is and see what we need to multiply by. Now this does have a y-intercept. Notice it's about at 1/2, so that's what we're going to estimate it at. Notice we also don't have anything in our numerator yet, so I'm just going to put a placeholder there. So we're going to say it's a, and your y-intercept is always wherever the x's equal 0. So I'm just changing all my x's to 0, and that would be an a over negative 4. But notice our y-intercept was at a 1/2. So we need to think, what value does a need to have to make our y-intercept be a 1/2. So in order for this to work, a would have to be a -2. Because -2 divided by -4 would give that, oh, but I did make a mistake. We need it to be a -1/2. So we don't want that 2 to be negative. We just want a 2/4. So it's a -1/2. So we need the a, the number on top, to be a 2. Okay? And now we have the equation that's going to create that graph. All right, and let's repeat this again. So let's first look at our x-intercepts. It's crossing right there. It's crossing right there at 4. So our x-intercepts create factors in the numerator. So we're going to have x minus 2 for that spot where it crosses at x at +2, and an x minus a 4 because of where it crossed at +4. Now we'll look at our vertical asymptotes. We have 2 vertical asymptotes, one at x equals -2 and x equals 3. So that creates 2 factors, x plus 2 and x minus 3. Now we'll look at the whole. We do have a whole this time. A whole is going to create a factor in the numerator and denominator. So this is just at x equals 0. I have seen some students write it as x minus 0. Now, there's actually nothing wrong with that. That's technically correct, but it's more complicated than it needs to be. X minus a 0 is just equal to x. So instead, what I'm going to do is just put in an x on the top and the bottom. Okay, and that's from the whole. Our final step is we're going to look at the horizontal asymptote. Our horizontal asymptote is at y equals 1. Now, from up above, I said we want a over b. So this is supposed to be an a over b. So to make it a fraction, just put a 1 under it. Now the direction said to then multiply the a to the numerator, b to the denominator. Both of them are 1s. Anything times 1 is just itself. So I'm not going to bother to write those 1s up there. But we have verified that the coefficient of the numerator and denominator are just 1s. And that's done. That's the equation that makes that graph. All right, and now we'll do the final one. Checking for my x-intercepts first. So we have one x-intercept at -4, so I'm going to put the factor x plus 4 here in the numerator. Next, the vertical asymptote was here where x equals 3. So that'll create x minus 3 in the denominator. Now checking for wholes, we got this one at -2. So we'll have x plus 2 in the numerator and denominator. This one at a 1, so x minus 1 in the numerator and the denominator. And now finally, our horizontal asymptote, which is at y equals -2. So if y equals -2 is our asymptote, and we want it to be an a over a b, just put a 1 under it. We multiply the a to the top, so a -2, multiply the b to the bottom. B is just 1, so it won't change anything. And there's our equation for that graph. All right, I hope this helps with your understanding of how to graph rational functions and how individual factors in different places of the rational function can change the graph.